Welcome to Kit 203 ICT Project Management and Modelling. In this video, we're going to be looking at many different diagramming methods that can have a role in project time management. My intention is to tell you what each type of diagram is particularly useful for and give you a brief understanding of how to do it. This is the contents of the video. We'll talk about network diagrams, three-point simulations, Gantt charts, critical paths, and PERT charts. Here we are on our content map. You can see we're looking at time management.
For showing how activities are related to each other, the best way of doing that is through a network diagram. It shows the logical relationship between activities and what order they should be performed in. I'm going to show you two different ways of doing network diagrams: arrow diagramming method, or activities on arrow, and precedence diagramming method. You'll see both of them used in real life, but the precedence diagramming method tends to be a bit more useful for our purposes. This is the arrow diagramming method. It's also called activity on arrow, AOA, network diagrams. Activities are represented by arrows. Nodes or circles are the starting and ending points of activities. It can only show finish to start dependencies. And this is how to create an activity on arrow diagram. I think it's pretty straightforward. You identify the activities that start at node 1 and you draw the nodes that they finish on. Then draw arrows between the node 1 and their finish nodes. Name each arrow and an estimation for completion, how long it takes, and keep doing that until you're done. Remember that a burst is where one node leads to more than one activity, and a merge is where two or more activities merged into a single node. You should have all of your arrowheads facing towards the right, and no arrow should cross. And this is the precedence diagramming method, or the PDM. Activities are represented by boxes. Arrows show relationships between activities, and it's more popular than the ADM method and used by project management software. It's better at showing different types of dependencies. Dependencies can be quite complex in the precedence diagramming method. Finish to start are the obvious ones, where you finish one task before the next one starts, but the others require one task to start before another can start, or one to finish before another can start, or one to start before another can finish. Three-point estimates are a useful way to develop timeframes in which projects may be completed. There's an optimistic option, the most likely option, and the pessimistic estimate. It's useful because it indicates the uncertainty surrounding some project activities, and it lets people build reasonable expectations for the duration of the project. We need three-point estimates for PERT charts, but we'll talk about them later. Gantt charts show how long tasks are expected to go. The relationships between tasks, milestones, and summary tasks are all presented here on a calendar. They're very useful for seeing which tasks have been completed and which haven't yet. It's part of the standard view in Microsoft Project and most other project management software. Gantt charts provide a standard format for displaying project schedule information by listing project activities and their corresponding start and finish dates in a calendar format. The symbols include the black diamond, which is a milestone, the thick black bars are summary tasks, and the lighter horizontal bars are the durations of tasks. Arrows show the dependencies between tasks. Many people like to focus on meeting milestones, especially for large projects, because milestones emphasize important events or accomplishments on projects. We'll normally create milestones by entering a task with a 0 duration, or you can mark any task as a milestone. Remember that your milestones should be SMART, specific, measurable, assignable, realistic, and time-framed. Schedule risk is central to the development of complex systems. Best practice suggests that project managers can reduce schedule risk through project milestones, which involves identifying and tracking significant points or achievements in the project. These are the 5 key points of using project milestones. Define the milestones early and include them in the Gantt chart. Keep them small and frequent, and they must cover all parts of the project. Each milestone must be complete or not complete. You can't have a partially achieved milestone. And what's your critical path? Remember, your critical path is the longest time to complete a project. Oh, it's here as well. Your critical path is the longest chain of tasks throughout your project. These tasks will determine the length of your project. The project cannot be finished until all of the tasks on the critical path have been completed. It is the longest, but not necessarily the most important path through the project. There is no slack or float time on your critical path. Other non-critical paths will have slack or float so that they can align with the critical path. The critical path is not the one with all the critical activities, it only accounts for time. There can be more than one critical path if the length of two or more paths are the same and longest. The critical path can change as the project progresses. And this is how you calculate your critical path. You take your network diagram and work out how long it takes to move through each path on the network diagram from the activity durations. The path that takes the longest is the critical path. If something is on the critical path takes longer than expected, then the length of the project will increase, unless some action is taken to make up that lost time. Okay, see this? You can work out the length of the paths by adding them up like this. 1 plus 4 plus 6 plus 3. And then 2 plus 5 plus 6 plus 3. And then 2 plus 4 plus 3. And then 3 plus 6 plus 2 plus 3. Now, they're the different options down there. And you can see that the one that took the longest is 16 days. BEHJ. So BEHJ is the critical path. If you want to finish your project faster, you need to decrease the length of the critical path. These are the ways that you can decrease your critical path. You can add more resources to tasks on that path, or you can fiddle with the scope of the tasks and change the duration that way. When we add additional resources, we call that crashing. We usually do this by taking resources from other parts of the project and putting them on the tasks to be crashed. We can also fast track activities and do them in parallel to get tasks finished faster. But of course, it's more difficult to move resources around to get things done in parallel. So you might need to get extra staff. Now, the critical path, while not necessarily containing the most important tasks in the project, definitely contains the tasks that take the longest. If we make changes to that critical path, then the project completion date will change. If it looks like our project is going to take too long, we need to discuss it with the project sponsor. Some projects will be time critical, and this will be very serious. Others have penalties for being late. Depending upon the outcomes, what the outcomes are for a late project will determine how many resources we add to the project to get it back on schedule. The PERT technique, Program Evaluation and Review Technique, allows us to try and schedule our project when we are in conditions of uncertainty in the project. With PERT, we work out optimistic, likely, and pessimistic durations for the project. We talked about this earlier as the 3 point. PERT works on a formula for calculating how long things should be indicated on the network diagram. Okay, so we calculate the PERT weighted average, the optimistic time plus 4 times the most likely time plus the pessimistic time divided by 6. And so if it's 8 work days plus 4 by 10 work days plus 24 divided by 6, it gives us 12 days, where the optimistic is 8, most likely is 10, pessimistic is 24. So in this situation, we would use 12 days on the network diagram instead of 10 when using the PERT method.
And that's it for this video. We talked about network diagrams, 3-point simulations, Gantt charts, critical paths, and PERT charts. If you have any questions, please ask. Thanks for listening.